Supplemental math videos from Circle Christian School. Welcome to the Pythagorean theorem. Have two sides of a right triangle? Just use the Pythagorean theorem. A squared plus b squared equals c squared. And although Pythagoras is credited with the formula, the Egyptians probably used it first. To use the Pythagorean theorem, you basically have to know the parts of a right triangle. And on your little tabby here, you can put an a squared and a b squared equals a c squared. All right, parts of a right triangle. Well, first we have the angles, and those are always in capital letters. Generally, C is going to be the right angle, the one that's 90 degrees here. The lowercase letters are going to represent the sides opposite the angles. So for instance, for angle A here, opposite it will be side A. Opposite B will be side B, and opposite angle C will be angle C. Remembering that in the previous chapters, we learned that there's this direct relationship between an angle and the opposite side. Have a big angle, you have a big side. Have a small angle, you have a small side. So there is this ratio that happens, there's that similarity thing, that allows Pythagoras to figure out that if I take my first leg, a squared, and add it to my second leg, b squared, it will always equal the hypotenuse squared. The legs are always attached to the 90-degree angle. Think of it this way. It's like the walls in a room, and the 90 degrees here is the corner. Well, without those two sides of the room, you wouldn't have a corner. The hypotenuse is always the largest side, and he's always across from the 90-degree angle. And it's kind of good to learn how to spell hypotenuse. It's really kind of like it sounds, but I always kind of did this backwards thing. Use 10 pots on high heat because I always had a hard time remembering how to spell hypotenuse. Pythagorean triples are when on a right triangle, the leg, and the hypotenuse end up being all whole numbers, not some sort of radical thing. One of the most special ones is what we call the 3, 4, 5. Now, note the order here. They always go leg, and then hypotenuse. There are several different spins on the 3, 4, 5, and that's just because you can scale factor them. Remember, a scale factor is a similar and proportional shape, or triangle in this case, where every side is multiplied by the same number. So if we scale factor this at a 2 to 1, another Pythagorean triple would be 3 times 2 is 6, 4 times 2 is 8, and 5 times 2 is 10. There's infinitely many of these, just depending on what your scale factor is. Another good one to know is the 5, 12, 13. These get used a lot also. Besides the two basic ones, I would really just work with the formula. Solving sides on a right triangle means you're just going to find a missing side or a hypotenuse. So you just have to discover which ones are legs. So this is a leg because it's hooked to the 90-degree angle, and this is a leg, and this is a hypotenuse. So putting it back into the formula, a leg squared plus an x squared, the next leg squared, would equal 5 squared. And now we're just going to solve for the variable. Fence of equality. And we get a 3 squared is 9 plus the x squared equals the 25 squared. The 25. And we're just going to take away the 9 from both sides here. And we get x squared equals 16. Oh, it looks like a perfect radical. And then we're just going to square root both sides. That's the inverse that happens there. And you find that x equals 4. Now in algebra, you may remember that this might be a plus minus 4. But because you can't have a negative side, it's just always going to be the positive value. We can find the missing side so that we can find things like perimeter and area. Remembering that perimeter of a triangle is a plus b plus c, the 3 sides added together, and area is 1/2 the base times the height, bh. So on my first triangle here, we're missing a height. So I'm going to just take my leg, add it to my other leg squared, and then my hypotenuse squared. And you can almost quick step this at this point if you wanted to. Minus a 12 squared. You just have to remember that the squaring kind of happens first here. And so basically what you have is h squared equals 13, which is 169, and the 12, which is 144. It's good to know your square roots up to 15 squared. Now gives us 25, and we're going to square root both sides, so h will equal 5. That's great. We found a side. But what we have to remember is that it wasn't just finding a leg here or a hypotenuse. It was that we needed to find the area, or maybe the perimeter. So in this case, the perimeter would be the 5 plus the 12 plus the 13, or 30. And the area would equal 1/2 the base times the height, so 1/2 12, which is 6, times 5 is also 30. Isn't that neat? It ends up being the same thing. Doesn't always happen that way though. And the first one would be units and the second one would be units squared. Let's try the next one, where again we have an isosceles triangle, but if we draw a perpendicular bisector inside of it, then we have a midpoint here, so we know we've got a 6 on both sides. But what we need is basically this triangle right here to be able to find things like the perimeter and the area. We'll need the height. So the height, again, is going to be a right triangle type of thing. So we have an a squared, a leg, plus our height squared, something missing, and a hypotenuse squared. So that would be 36. This would be 100. I'm going to minus the 36, and I'm going to minus the 36. I want you to work on a little bit of mental math here. H squared is going to equal 100 minus the 36, which is going to be 64. Square root both sides, or quick math would go, square root of 64 is 8, or what squared would equal the 64. And so we have 8 equals the h. So we can go find the perimeter because it was an isosceles. We know we have 10 plus 10 plus 6 plus 6, or 20 plus 12 for 32. I'm going to call it units. And area is going to be 1/2 the base. So 1/2 6 plus 6 is 12, and 6 times the 8 equals 48 units squared. We can also use the Pythagorean theorem to see if what we have is a right triangle or a 90-degree angle. This is called the Pythagorean theorem, Converse. By using the Pythagorean theorem, we're going to see if we have a right angle here. Now, the setup here is you'll be going, well, gee, how do I know which one are the legs and which one might be the hypotenuse? Remembering that the hypotenuse is always the larger number will allow us to make a setup here. So I'm going to check to see if 6 squared plus 8 squared equals the 9 squared. All right, so we have 36 plus the 64, and does that equal 81? Does 100 equal 81? Well, no. So I don't have a right triangle. But looking at the numbers here, that if we have the a squared plus the b squared and it's bigger, then what we have is an acute triangle. And if it's the other way, that the a squared plus the b squared is smaller than the c squared, then it's obtuse. Cool little things. Just an add-on to the last one. If at any time you kind of get a little bit lost in what happens with radicals, take a look at the video that's before this one. It's all about radicals and simplifying them. That should be a big help too. Have an awesome day.